This time we have another function. The function is also a rational function. You have your f of z is equal to 2z minus I all over z plus 2i. We're going to find the derivative of this using the definition. The definition of the derivative is expressed in this manner. It's actually the limit of your f of z plus delta z minus f of z all over your delta z as delta z approaches to 0. This is similar to the previous example, which is also a rational expression. So if you would like to view that first before this one, so you'll be guided on the similar processes here. In order for us to identify a derivative, please do so. This is because, take note that our function here, or the numerator, will have two different functions. We have this function which is originally the given, but this one is also another function. So we're going to find that first, get that value of that. If we're going to integrate the result of these two in our numerator, it will become a nested rational expression. So it will take us a lot of time to solve for this, especially that our goal here is to make sure that this would be removed, because as that value approaches 0, this would be undefined for this specific instance. So what we can do here is, again, use a scratch portion here if you may. Let's solve first for f of z plus delta z for our f of z given as 2z minus I, if I'm correct, all over z plus 2i. So what we need to do here is, instead of z for this given forms, we will be substituting this entirely, this binomial expression. So this is equivalent to 2 times z plus delta z. By the way, we're doing this outside of this form, again, as mentioned, so that later on, our nested rational expression here is not that difficult to look at. Okay? So you have here minus I all over, your z becomes z plus delta z plus 2i. Simplifying that, you will have 2z as distributing that 2 is plus 2 delta z minus I, and our denominator is z plus delta z plus 2i. Of course, we cannot cancel any term here from the numerator and denominator, so this would stand to this expression. Using that now, returning here, as we start finding the derivative, let me start here with this notation because I need to come up with a nested rational expression here. For this form, is already identified here. And that's actually twice z plus twice delta z minus I, if I'm correct. Yes. All over z plus delta z plus 2i. Let me check again. That's correct. But that's just for this form. Take note, we still have minus z, which is just the original rational expression, minus twice z minus I over z plus 2i. And take note, we still also have all over delta z here. As mentioned, this is an nested rational expression. And again, we cannot find the limit in the meantime because this would approach to 0. That would be undefined. So what we can do here is actually to apply mathematical operations in order for us to guarantee that this later on may be removed or may be cancelled out from the result of this. So let us start by simplifying the numerator, the entirety of the numerator. Let's simplify that first, and later on return to this if we can actually look for something else or other methods to cancel this. So allow me to use the rest of the open spaces here. So you have here this form, actually twice z plus twice delta z minus I all over z plus delta z plus 2i. This is to be subtracted by the original form, original function, minus 2z, this one here, minus I all over z plus 2i. To combine them, we need LCD, right? So the LCD of that is just simply the product of the denominators. In the meantime, let's not multiply them. We will do that later on. Sorry, this is 2z if I'm correct. 2i times z plus 2i. Let's multiply them later together with what will happen in our numerator. Looking for LCD, this would be multiplied to the first numerator, and this one here would be for the second numerator, as long as they are separated by subtraction. So you have here z plus 2i times the original numerator, 2z plus 2 delta z minus I. Take note, this is very long, okay? Minus the grouping symbol 2z minus I. Take note, you group that, okay? Times the denominator of the second one, z plus delta z plus 2i. Okay? So, this time, let's try to multiply all the terms by distributive property. Allow me to distribute this first, and then to all the three terms, and later on the second term. Similar here, but sticking with what with that symbol later on. I'm gonna stay minus as it is. For our denominator, we'll be having the left distributive property together with the second term. So what will happen here is actually this one. Let me erase this for to save some spaces. For numerator, z times 2z is 2z squared. Then you have here plus 2z delta z and minus zi. Okay? Distributing that, right? Next, the second term plus 4. 2 times 2, this one here. 2 times 2 is 4zi or iz. It's up to you. I'm just going to use here zi because I is a unit for imaginary number. Okay? Or you can, of course, use iz. Let's use iz just to rearrange the terms, or I mean the coefficients alphabetically. So this zi here, let me also write this as iz, right? Iz. So 2i, so we have here plus 4i delta z, and you will have here minus 2. Okay, that's just for this first group. What would happen here? I don't have much space. Anyway, allow me to continue. So 2i squared. Okay, minus the second grouping symbol. You have here 2z squared, this one here. Again, sticking with the negative in the meantime and having a grouping symbol. So we have here plus 2z delta z, and you have here plus 4iz. Then this one here, minus iz, minus I delta z, and minus 2i squared. These are all over the product of your denominator. That's z squared. Yeah, I will be using an additional page for this, so pardon for that, because I don't have much space here. So again, distributing that first, you have your plus z delta z and plus 2iz. The second one, plus 2iz, this one, and then plus 2i delta z, and you have here 4, plus 4i squared. That's 2i times 2i. Allow me to copy this, sorry for this, and copy that and add another page because we need to have additional steps. Okay, alright, removing this. Alright, now looking at our numerator, let's find out if there are terms that could be removed just by looking at the first form. I. So there's no other terms that could combine unless we try to start removing this grouping symbol. And by the way, we know that I squared is negative I, right? But let's not simplify that because later on I think it will be cancelled here. So let's just simply do it like this. 2z squared plus 2z delta z minus iz plus 4iz plus 4i delta z minus 2i squared, right? Then removing the grouping symbol, meaning distributing all the negative signs there, we'll have minus 2z squared minus 2z delta z minus 4iz. This becomes plus, so plus iz plus I delta z and plus 2i squared. Again, for our denominator, it's still for our denominator, this is the time we can combine them. Let's combine them, okay? We can combine, I'm talking about sorry, not that one, this one here, okay? So, and at the same time, we know that I squared is negative 1, okay? We know that I squared is negative 1. So let's apply that. And of course, again, combine this. For our denominator, you will have here z squared plus z delta z plus 4iz, 2, that's 2 plus 2, plus 2I delta z, and you have your minus 4. Okay? It's now minus 4 because I squared is negative 1. Okay? Now, look in our numerator this time, 2z squared minus 2z delta z is this. Iz minus is plus. What else? 4iz is minus 4iz. And of course, as mentioned, the minus 2i squared is plus 2i squared. Okay? So, our final form here is just the remaining term, 4i delta z, this one. And then this one here, plus I delta z, all over the same denominator. Plus, sorry, that's z delta z plus 4iz plus 2i delta z minus 4. Okay? This is just as mentioned and very important to clarify. This is just equivalent to your entire numerator. So we're going to return here the limit again as delta z approaches 0. You will have here your entire numerator, which is this one, 4i delta z plus I delta z. So you have here 4i delta z plus I delta z all over, sorry, you will have here this one, z squared, sorry, z squared plus z delta z, then plus 4iz plus 2i delta z and minus 4. But take that again, that's just the numerator. We still have here over delta z. Okay? Now, in the previous video, you're also able to talk about this. And the reason why we need this one here, because some concept will be applied here. The keep, change, flip method, you are having nested rational expressions. So you're going to change the operations division and reciprocate the denominator. Or you can also use this concept, 1/2 over 3. Of course, when you do the keep, change, flip method, that's 1/2 times reciprocal of denominator is 1/3, right? Or simply take out that 3, making it 1/3, because you have here 1/3 somewhere here. My point for that is when you go to this example, you will have your denominator of delta z. Simply take that out, making it as a rational expression. So you will have here times 1 over delta z automatically. Or if you would like to stick with this, of course, change the operation to multiplication and reciprocate that, so the same thing will follow. The point for that is, take note that we are finding the limit and we would like this not to be 0. We could see that our numerator now has a factor of delta z, where we can factor out the limit of delta, this one here. When we factor delta z, you have 4i plus, 4i plus I, right? We can add, sorry for that. We can actually add then the numerator here. This is supposedly equivalent to 5i delta z. Okay, I forgot to add them. Basically, that's just 5. So from here, allow me to change this. Sorry for that. I was not able to really look into this carefully. It's just the sum of that is actually equivalent to 5i delta z. So we don't need to factor that. We can just automatically cancel this, or let's use the red one. Cancel this, okay? Because I wasn't able to add it. We have 4i delta z and I delta z. Clearly, it's just 5i. Sorry for that. 5i. So what remains for our numerator is just 5i over the entire denominator here. Take that our goal is to find the limit, and we don't want our denominator to become 0 as delta z approaches 0. That's why we're doing all of this. Now, when you have this next form, we still have delta z in our denominator, but it will no longer be 0 because it has other terms without delta z. To apply now the limit, so you have 5i here, applying the limit for this, that's approaching 0, and this one. So what we have here is z squared plus 0, that again, that's 0, plus 4iz. This is also 0 minus 4. So our final answer, or the derivative of the given rational expression, is 5i over z squared plus 4iz minus 4. Okay? This is the derivative of the original function 2z minus I all over z plus 2i using a definition. Take note, this is very long because we're using definition, and we were able to use some nested rational expressions together with this final form only of the numerator. Again, this is the better answer for that. Okay, and we have this. Of course, you can use the other rules for differentiation if you can still remember the rule for quotient of functions, specifically here, complex functions. You can do that to verify whether the answer is correct or not. But this is the process using the definition. Thank you very much for watching.